Hello all, myself Nivisha from CSC Department third year. I am excited to share my mini project with you and today my project title is Alzheimer's disease detection using deep learning. These are the agendas which we provided in Alzheimer's disease detection using deep learning. And first one, the introduction. In this section, we will provide an overview of Alzheimer's disease, its impact, and the importance of early detection. We will also introduce the objectives of our project. Problem statement. Here, we will discuss the challenges associated with the diagnosis Alzheimer's disease, including the gradual decline in cognitive functions and the need for timely intervention. We will highlight the significance of our project in addressing these challenges. And literature review summary. In this part, we will summarize exciting research and methodologies related to Alzheimer's detection. We will discuss the current state of the art in medical imaging and deep learning techniques that have been applied in this field. Methodology and flow. We will outline the methodology we adapted for our project, including data collection, pre-processing, model development, and evaluation. This section will provide a clear flow of how we approach the problem, and algorithms used. Next, we will dive into the specific algorithms, and we employed in our model, including conventional neural networks and recurrent neural networks. We will explain why these algorithms are suitable for our task and implementation. In this section, we will present the implementation details of our model. We will walk through the code explaining how we build the model architecture and the rationale behind each layer. And output. Here we will discuss and showcase the results of our model, including performance metrics and visualization of the predictions. We will discuss how well our model performs in detecting Alzheimer's disease and completion. We will summarize the key and finding our project, emphasizing the contributions of our work to the field of Alzheimer's detection. We will also discuss the implications of our results for healthcare professionals and references. Finally, we will provide a list of references that informed our research and methodology. This will include key studies and sources that have contributed to our understanding of the topic. Next, the introduction of the mini project. The title is Alzheimer's disease detection using deep learning. Alzheimer's disease is a progressive neurodegenerative disorder that leads to cognitive decline, and it can affect individuals at any stage, and its early stages are often difficult to identify. Our project aim is to develop a system that can detect early signs of Alzheimer's disease using deep learning techniques applied to brain MRI scans. The statement of the problem. What are the challenges in current diagnosis we are facing? Means Alzheimer's disease gradually impairs thinking and memory, making everyday takes difficult. Early detection is vital as it opens up options for clinical trials and gives caregivers time to prepare for the changes ahead. However, current diagnostic methods are often time consuming and subjective, leading to potential inaccuracies. Scope of the project is the proposed deep learning. One of the solution is our solution leverages deep learning techniques to analyze MRI scans of the brain. By utilizing conventional neural networks and recurrent neural networks, we aim to improve the accuracy of early Alzheimer's detection and reduce cost and access to healthcare professionals in the diagnostic problems. In the scope of the project, there are five scopes. One is early diagnosis, enhanced accuracy, efficient screening, support for healthcare professionals, and another one is cost reduction. This is the methodology of the Alzheimer's disease detection using deep learning. This project methodology involves several key steps. One is data collection and data preprocessing and model development. In data collection, we'll gather a comprehensive data set of brain MRI scans for individuals with and without Alzheimer's disease. And data preprocessing, this includes cleaning and standardizing the imaging data for better model performance. In model development, we will design a deep learning model and primarily using CNS for image analysis and split the data set into training, validation, and testing sets. This is the architecture diagram or flow diagram of Alzheimer's disease detection. In input data, there are two layers. One is conventional layers and pooling layers, and fully connected layers. One is Alzheimer's disease, and after fully connected layers, Alzheimer's disease with the patients is affected with the disease. The patient who is not affected with the disease, that is no disease. And this is a use case diagram for starting the process of logging. Design use case diagram and class diagram and sequence diagram. What are the algorithms we used in this Alzheimer's disease detection is one is conventional neural network and recurrent neural network, and we will also explore some ensemble methods to combine predictions from both models for enhanced accuracy. Conventional neural networks is for analyzing 3D MRI data and extracting spatial features, and recurrent neural networks is to handle sequential data and capture temporal changes in brain activity. And implementation of the algorithm implementation in this, let's take a look at the implementation of a deep learning model for detecting Alzheimer's disease using keras. This model utilizes conventional neural networks and recurrent neural networks to analyze brain MRI scans. We start by importing the necessary modules from keras. The sequential model allows us to build a linear stack of layers while convolutive max pooling to do flat and dense, simple RNN and time distributed. These are the layers we will use to construct our model. And we define a function called build model that initializes a sequential model. There are conventional layers. First layer is conventional layer with the 16 filters, kernel size of 3 into 3, and ReLU activation. The input shape is set to 128 into 128 pixels with the 3 color channels RGB. And we follow this with a maximum pooling layer to reduce the spatial dimensions. In second conventional layer, increases the number of filters to 32, again using a 3 into 3 kernel and ReLU activation followed by another max pooling layers. In third conventional layer using 128 filters followed by max pooling, further reducing the dimensions of our future maps. We then add a time distributed layer to flatten the output of the conventional layers into 1D array, making it suitable for the subsequent RNN layer. Next, we add a simple RNN layer with the 64 units. This layer will process the sequential data obtained from the memory scans. We then add two fully connected layers. The first is with the 128 units and the second with the 64 units, both using ReLU activation. Finally, we have an output layer with the 4 units and a softmax activation function, which is suitable for a multi-class classification. And then this model is compiled using the Adam optimizer and sparse categorical across entropy as the loss function. We also track accuracy as a metric. Finally, we bring the model summary to visualize the architecture and data the model instance. We call the build model function to create an instance of our model, which we can then train using our data set. This is the output of the project of Alzheimer's disease detection. Alzheimer's disease detection using deep learning. We anticipate this is the predicted values, and we anticipate that the model will provide a reliable predictions regarding the presence of Alzheimer's disease based on MRI scans. The success of the model could lead to timely interventions and uh, better management of the disease. And in this project, we are using some SDG codes. One is SDG 3, 9, 10, 4, 17. SDG 3 is well-being and health. SDG 9 is infrastructure, industry, and innovation. SDG 10 is less disparities. And SDG 4 is quality education, improves medical professionals training in AI healthcare. And SDG 17 is collaboratives to achieve the goals. In conclusion of our project, proposes a deep learning based approach for the early detection of Alzheimer's disease using brain MR images. In this, the integration of CNN and RNN architectures has shown promise in improving diagnostic accuracy, which can significantly benefit patients and healthcare providers. Looking at, we plan to incorporate in future work. We plan to incorporate more diverse data set and explore additional deep learning techniques. to enhance our model's performance. We also aim to investigate other imaging modalities and their effectiveness in Alzheimer's detection. We have referenced several key studies and sources that have informed our project, ensuring that our approach is grounded in the current scientific literature. Thank you.